All right, students, here's what we're going to do. We want to spend some time with the Pythagorean theorem, extra practice. And the first example we're going to look at is a little bit different than the examples we've looked at thus far. In this particular example, we are going to go ahead and we are going to try to find one of the legs, A. So in all the previous examples I've shown you, we have found the hypotenuse. But in this particular example, I'm going to give that to you. Okay? So again, we're going to start with our normal equation, and our normal equation would be something like this. A squared plus B squared equals C squared. Now, in this particular example, we know B to be 8, and we know C to be 10. So we're going to plug those values in. We're going to copy everything down. A squared plus 8 squared equals 10 squared. Now, we're going to go ahead and copy everything down, but simplify this time. So 8 squared right here, 8 times 8 is going to be 64. 10 squared right here is going to be 10 times 10, which is 100. Now, here's where it gets a little bit tricky, right? We still need to try to find A squared, or A, but we have a 64 on the same side of the equation. And so what we're going to do is we are going to make a change to both sides of the equation. We are going to subtract 64 from both sides. That's really important for us to understand here. We are going to subtract 64 from both sides. Golden rule, what I do to one side, I must do to the other. This is a very important rule of mathematics. All right, so if I subtract 64 from one side, I must subtract it from the other. Okay, 64 minus 64. So right here, this is going to end up being 0. So we're going to be left with A squared equals 100 minus 64 is going to leave us with 36. So we're going to go ahead and copy down 36. Now, just like in our previous problems, we want to get rid of this squared value, but we can't just get rid of it. We have to do something to get rid of it, and we need to cancel it out. So the way that you cancel out a square is you take the square root. So we are going to go ahead and take the square root of this side. Now, what I do to one side, I must do to the other. So I'm also going to take the square root of 36. The beauty of this particular equation, and the way that this works, is that this squared value is going to go away, and this square root is going to go away, and I'm going to be left with A, and the square root of 36 is 6. So A equals 6. So the original problem was find the value of A, and we found the value of A right here. So you can come back over and we can put it on there, and we have a 6, 8, 10 triangle. All right, students, we're going to go ahead and look at example number 2. In example number 2, we're going to try to find the height of this apple tree. So if we go ahead and take a look here, the apple tree has an unknown height, but we're going to use some dimensions that we know about the tree to calculate the height. And so we are going to go ahead and calculate the height of the tree using this triangle that we have here. So let's go ahead and do this. First of all, we need to write our equation. A squared plus B squared equals C squared. Always start by writing your equation. Next, identify what values you know. So usually, or typically, the smallest side, A, is going to be the smallest side. The second smallest side, the middle side, is typically B. And in this particular case, we're not going to call it B. We're going to call it H. So I'm going to go ahead and replace it with the value H. And the last one we know as the hypotenuse. C is the hypotenuse, the longest side, and that would be 13. So we're going to try to find height and use this equation. Okay. One thing you can do right from the get-go, and we didn't do this in the last example, one of the things you can do right from the get-go is you can subtract one of the legs right from the beginning. So let me show you what I mean. We want to find h squared. And h squared and a squared are being added. For the sake of argument, let's go ahead and put them in boxes. A squared is kind of its own thing. And we're adding to that h squared. I'm going to put that in a box. And that equals c squared. And we're going to put that kind of in a box. And so each box has a value. Well, if I want to get h squared by itself, so if I want to get this value here by itself, addition is happening here. And the opposite of addition is subtraction. So I can actually subtract a squared from this side. And what I do to one side, I must do to the other. I'm going to subtract a squared, actually. And that means I must also subtract a squared from the other side. What I do to one side, I must do to the other. And I am now left with h squared equals c squared minus a squared. Now, you may be looking at this and you may think, Mr. Bornheimer, that looks way too hard. Well, it's not really a whole lot different than what we did in our previous example, is it? Where we, if you look closely here, we subtracted a value here and we subtracted a value here. The difference being in this particular example is the difference being that we knew what the value was when we subtracted it. In this second example, we don't know what the value is yet, but we're about to find out. Okay, I can now plug in the values that I know. I do not know h, so that's going to stay the same, but I do know c squared to be 13 squared minus 5 squared. If I take this and simplify it a little bit further, I get 169 minus 25. The nice thing about rearranging, let me go ahead and write a little note here. The nice thing about rearranging values at the very beginning is that it makes the math simpler later. Okay, so it is really nice. It's really nice to rearrange the equation early on. If you think that's too confusing, you can plug in the values to A and to C and work the problem like we did in example 1, where we plugged in the values for a squared, or 8 squared and 10 squared, figured out that was 64 and 100, then subtracted. So you really have two choices here. You can rearrange the equation first, like I did here, and it makes the math simple later on, or you can plug in the numbers early on and solve. Now, if we continue with this line of math, h squared is actually going to equal 144. I want to focus in on this for a second. That means that h times h equals 144. And maybe you know what number times itself is 144. Maybe you know, and you don't have to go any further because you know what h is going to be. But if you do not know what h is, then we take the next step. And the next step is that we need to cancel out this squared value. And to do that, we must take the square root. Square roots cancel out squares. What I do to one side, I must do to the other. That goes away and that goes away. And I'm left with h. And the square root of 144, if you plug it into your calculator, is 12. So the height of our tree is 12 units. All right, students, the last example for this particular lesson is going to be using the Pythagorean theorem to figure out whether or not a triangle is indeed a right triangle. So the Pythagorean theorem tells us the relationship between the three sides of a right triangle. If the Pythagorean theorem works, then that you're actually dealing with a right triangle. If you plug all the numbers in and it doesn't work, then the triangle is not a right triangle, and those are not the proper measurements. And so let's go ahead and try this. We start with a squared plus b squared equals c squared. And we identify our values, 3, 4, and we'll leave c as black. And so what we're going to do is we're going to plug in these values. So 3 squared plus 4 squared equals 6 squared. Now, if we do the math for this, and it ends up that the left side equals the right side, okay, so again, we have left equals right, then we know that this is indeed a right triangle. If the left does not equal the right, then we know this is not a right triangle. Okay, so we want to make sure that we're using the Pythagorean theorem to kind of mathematically determine whether or not these three measurements will form a right triangle. So let's go ahead and continue here. 3 squared, 3 times 3 is 9, plus 4 squared, 4 times 4 is 16, and 6 squared, 6 times 6 is 36. Now, 9 plus 16 equals 25. So we can see here that 25 is not equal to 36. So this triangle is not a right triangle. Let's go to the other side. We have 12 squared plus 16 squared equals 20 squared. Notice this time I didn't use a squared plus b squared equals c squared. The important thing when you're doing this is that you are putting the longest or the greatest value in the c spot. So 6 for c, 20 for c. We're going to go ahead and continue with this. 12 times 12 is 144 plus 16 times 16, 256 equals 20 times 20. You should know this one. It equals 400. Now, when we add up 144 and 256, I'm going to use the calculator here because I want you to see this. 144 plus 256 equals 400. So we get 400 equals 400. And so therefore, this is indeed a right triangle. Okay, the measurements of those three sides make a right triangle. So you can use the Pythagorean theorem to check the measurements of right triangles, like this one and this one, to determine whether or not they are actually right triangles. And that is a great use for the Pythagorean theorem.